Alright, if you guys could please turn to the page in your notes that looks like this. 6.5, prove triangle similar by SSS and SAS. Alright, SSS, similarity. This is different from the SSS congruency theorem. This says that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. Okay, so in this case, if this side and this side and this side are proportional to these three sides, then these two triangles are similar. So, for example, is either triangle DEF or triangle GHJ similar to triangle ABC? What we need to do is we need to compare triangle ABC and triangle DEF by finding the ratios of the corresponding side lengths. So, AB over DE. AB is 8, DE is 4. This simplifies to 2 over 1. CA is 12. FD is 8. If you simplify that, you get, let's see here, divide by 4. You get 3 over 2. BC is 9. EF is 6. Divide both sides by 3. You get 3 over 2. All the ratios are not equal. So, triangle ABC and triangle DEF are not similar. In order for these to be similar, each of these ratios need to be exactly the same. Let's try the other two triangles. AB and GH. AB is 8. GH is 16. This simplifies to 1 over 2 if you divide top and bottom by 8. CA and JG. CA is 12. JG is 24. This also simplifies to 1 over 2 if you divide top and bottom by 12. BC is 9. HJ is 18. You divide top and bottom by 9. You get 1 over 2. All the ratios are equal. So, triangle ABC is similar to triangle GHJ. Make sure you put the letters in the correct order. Alright, let's go on to page 2. Find the value of x that makes triangle ABC similar to triangle DEF. Okay, first thing, we need to find the value of x that makes the corresponding side lengths proportional. 4 corresponds with 10. X minus 3 corresponds with 20. So now we can cross multiply. 4 times 20 equals 10 times x minus 3. I have to distribute the 10. 4 times 20 is 80. I have 10x minus 30. If I add 30 to, I'm going to add a step in here. If I add 30 to both sides, I get 110 equals 10x. And then if I divide by 10, x equals 11. Okay, we're going to check that the side lengths are proportional when x equals 11. If AB is x minus 3, 11 minus 3 is 8. If I plug in 11 here, 11 times 2 is 22, plus 3 is 25. BC over EF is 4 over 10. AB and DE (8 over 20). These are in fact equal. BC over EF, once again, 4 over 10. AC over DF, 10 over 25. And these are also equal. So, when x equals 11, the triangles are similar by the SSS similarity theorem. Alright, I will let you guys do the checkpoint. Let's go on to page 3. Alright, SAS. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. Notice that the sides have to include the congruent angles. That means that the angle needs to be in between the two proportional sides. Okay? So for example, you are drawing a design for a bird feeder. Can you construct the top so it's similar to the bottom using the angle, measure, and the length shown? Okay, in the diagram, both the measure of angle B and the measure of angle E equal 87 degrees, as you can see here and here. So, angle B is congruent to angle E. So we have one angle. Now we're going to compare the ratios of the sides, of the lengths of the sides that include angle B and angle E. These sides would be AB and DE. That's this side and this side. BC and EF. That's this side and this side. Okay, now we actually are given the measures of each of these sides. AB is 32. DE is 20. BC is 8. Or actually, you know what? They are the same thing. 32, 32, 20, and 20. This simplifies to 8 over 5. That's if you divide top and bottom by 4. Okay? So the lengths of the sides that include angle B and angle E are, in fact, proportional. So, by the SAS similarity theorem, the triangles are similar. So you can make the top similar to the bottom. Alright, I'll let you guys do the checkpoint. Let's go on to page 4. Okay, so we've learned 3 similarity postulates and theorems: angle, angle, side, 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 and side, angle, side. Tell what method you would use to show that the triangles are similar. Okay. You can kind of tell that you have at least one congruent angle because these are vertical angles. Let's take a look at the shorter sides. The shorter sides are QR and RS, which is 9 and 12. If you divide top and bottom by 3, you get 3 over 4. The longer sides are PR and TR, or RT. This is 18 and 24. If you divide top and bottom by 6, you get 3 over 4. So the corresponding side lengths are proportional. The included angles, angle PRQ and angle TRS, are congruent because they are vertical angles. So the triangles are similar by the SAS similarity theorem. Alright, you guys can do the last one, and that's all.